Okay, good morning, everybody. My name is John Messner. I'm a faculty member in the Architectural Engineering program at Penn State University. At Penn State, it was not until, if you look at these, it's not until the early 60s that we really spun off our architecture program. We moved them out of the College of Engineering and we moved them into the College of Fine Arts and Architecture. And so what happened there was a separation in the 60s of the programs, and that separation happened in many ways. It happened with our faculty, who are now highly segregated into two totally different programs. It's also more recently, since I've moved back to Penn State, has physically happened. And so this is an image of, an early image of the engineering units that are at Penn State. They look quite different now. This picture was from the 40s. These buildings, by the way, are as old as our program, and we still reside within 3 of those. So these 3 buildings were the architectural engineering program 5 years ago, and these 2 buildings were our architecture and landscape architecture program 5 years ago. And so we saw each other in the hallway a lot, and we had a lot of close collaboration. But since then, these 2 buildings are now a park. They've been demolished, and we built a new building that's up in this area, actually, for our architecture program and landscape architecture program. So I think this is really some of the challenges that we fight and that we struggle with in an academic community, as well as in many ways mirrors some of the things that have happened in industry. And we've all heard the discussions about the master builder and losing the master builder approach to delivering facilities. But we've also mirrored that structure in academia. And I think the thing that we need to consider is, how do we replace that and teach students in a manner that they can be more collaborative when they go out into the profession and work across disciplines while still maintaining some expertise in their own area. So in today's talk, one of the things that I want to do is just discuss some of the courses that we are creating. And I know this first part of the session is about some of the changes in the profession. And one of the things I want to talk about is some of the courses that we're creating in many ways to try to mirror some of the things that we see in maybe the most innovative projects that are going on in the profession, and to try to drive forward some of the tools and techniques that the profession can adopt. And so we saw this discussion that Phil had related to IPD, or integrated project delivery, and we are really aiming within several of our areas to embed not just BIM, but the underlying foundations of integrated project delivery. And I'm not using that term. That term can be easily confused with new contracting structures, but I'm looking at it from an integrative approach to designing and constructing a facility, not just the contracting structures that might reside around that. So I wanted to start with a brief discussion of the context in which we are implementing some of the integrated design courses. And this shows some of the curriculum elements that we currently have at Penn State. So at Penn State, we have 4 main departments that look at building of facilities. One of them's not really represented here, which is our civil engineering program, because they've taken a very different approach to things than we have in some of the other building areas. But what you do see at the bottom here is architecture. So we have an architecture program with an undergraduate and graduate program. We have a landscape architecture program with an undergraduate and graduate program. And then we have an architectural engineering program, and I've included our 4 options within AE into 2 categories. Many times we talk about Within AE, we have 4 options. We have structural, mechanical, lighting, electrical, and construction engineering. And we frequently refer to them as the 3 being the design options and the 1 being the construction option. And frankly, it's something that I hope we get away from, because I don't think that's necessarily a productive nor an accurate way to look at that problem. But within the curriculums, within architecture, they are embedding some building information modeling, mainly for design visualization in early studios. But it's really the 4th year where they start to look at integrating BIM a little bit more into some of the studio environments. And I just paint this picture because I'm going to be talking about 2 initiatives that we have. One is a brand new Capstone course that we put together where we have 12 students working as a team, and another is a collaborative BIM studio that spans across the 3 departments, which is a very significant challenge to orchestrate, but we've seen some really good results from that. So the first one I'll talk about is specific to architectural engineering. We have put together a new Capstone design course, which is a group-based studio course where we take 1 student from each of our 4 option areas. So a construction, a mechanical, a lighting electrical, and a structural student. We integrate them into a team and have them perform an analysis of a building and redesign of suggested improvements to that facility. This is the New York Times building, which was the focus of our Capstone design course this year. We will be changing that next year to a different project. But these 3 teams of 4 students really looked at this, and the first task was for them to evaluate the performance and how well that design was developed, considering all of their option areas, and then they proceeded to a redesign of that facility. One of the things that I wanted to point out within this is the first thing when we had them go through the development of this thesis, and we've termed this thesis an integrated project delivery / BIM thesis, because we wanted the students to think about the process of how they're working together. And one of the tools that we used to allow them to think about that process was some recent research that we completed at Penn State looking at the development of a BIM execution planning guide. And this guide really walks a team through deciding what they want to use building information modeling for, and then how they will actually implement this. I think this is when we start to look at how can we look at the theory or how things are changing within the design and construction process, I truly feel we need to step back and be able to take a systems approach to this and really analyze and in some ways engineer or design the processes that we're going to use to deliver these facilities. The interesting part of this is then everyone would analyze what the lighting impacts, the mechanical impacts, and the construction impacts are of these redesign alternatives. And so they were using building information modeling as an analysis platform to inform the design process. And I think that was really beneficial for them to do that. And in that way, it also taught them the impact of their decision on the broader context of all the different disciplines that were involved. They also did a lot of daylighting studies. This was a very important area where we would have our lighting electrical students focusing on the main daylighting studies, but then sharing them back with the group. But I think the most interesting thing here is in our existing thesis, we currently have students doing these types of detailed analysis for their own area. But in this thesis, they had to do it in the context of how it impacted everybody else's tasks and discipline areas. And so that really made a big difference. So another initiative that we have is we are in the second year of implementing, which is an integrated BIM studio, which actually spans all four of the areas that we talked about. So in this initiative, we have 6 students. One is an architect, one is a landscape architect, and then we have one of each of the 4 options within architectural engineering. So we're running this as a design studio environment. Students come down, you can see this is our immersive construction lab that we have at Penn State, which is an interactive workspace that the students can work in, where all the students come in, they get tablet PCs, they are engaged in a design process together within this space. Obviously, they each go off and they perform detailed analysis in their area, but they're coming back together as an integrated team at least twice a week to work on these design projects. And the focus of this, we started this initiative 2 years ago. We wanted to create this, one, to look ourselves at what is the value of these integrated design thesis, but also to inform our own programs on how we need to change the education process within the programs to prepare students for these late-stage integrated design studio courses. So we've done a number of things in order to ensure that the students are prepared for this type of collaboration. I think some of the key student feedback is really that students learn a lot about collaboration within this process. This is, in many ways, a frustrating experience for a number of the students. Many of the students have to learn or are working to learn within this environment how to collaborate with others, and they have to learn how to sometimes do a negotiation of give and take within the design process that frequently the students don't need to do when they work on their individual projects. And so they may see that they need to give up elements that they feel are really valuable because of the mechanical or the cost implications of integrating some of those features into the design. And so I think it's really a beneficial experience for them to see that. But in many ways, that can also be a challenge. One of the other things that we did with this course is we really focused on developing team skills. And so we have some collaborators in industrial psychology. Sam Hunter is the leader of the group that we work with in industrial psychology. But he is also using this course for his students who are focused in investigating teaming and innovation and its relationships. So he'll send groups of industrial psychology students into our classroom to observe the students, and then they report back to the students some of the things that they've learned about how the student groups are working as teams. And so this has been fascinating to us to be able to see the types of conclusions that the industrial psychology students are bringing to our attention on how these teams interact and sometimes don't interact in a manner that we want them to. But I think it's also interesting for the students because it, one, raises the awareness of them, of the value of them learning how to function as an interdisciplinary team. And then they also get feedback. And we use a number of team-based feedback metrics and mechanisms to give them that feedback. And I just want to end with a closing thought or comment. This was actually from one of the landscape architecture graduate students that looked at, in his 6 years of experience, even with that, he had a number of things to learn. I hope he always has a number of things to learn in his career, but it was collaborative learning at its best, based on real-world principles, pushing the boundaries of technology in the design process. This studio, more than any other studio, has the potential to solidify each discipline's ideas and methods in the context of the collaborative professional design team. And that's really what we were looking at doing, creating something where students learn about all of the disciplines, but are still targeted in performing the tasks of their own discipline, so that we can better integrate these students into teams as they proceed into the profession.